We are trying out a problem here associated with the conservation of energy and friction. So here in the figure that we have right in front of us, we have a ball that is released from the point A on the track. We are to find out the distance that it will travel on the inclined plane before it stops momentarily. Now, from the figure that we have in front of us, the radius of that quadrant that we can see, that is 6 centimeters. So 6 centimeters horizontally and 6 meters, beg your pardon, 6 meters horizontally and 6 meters vertically. And then you have a plane surface, a straight surface, horizontal one at the bottom, which runs 10 meters, but with a friction coefficient which is 0.4 between the ball and the surface. And then you have the incline at an angle of 30 degrees, and that is smooth, that has no friction associated with it. So in order to solve this, we proceed as follows. First of all, we'll use the conservation of energy, and we can obtain that as let me use another ink for that. So as the ball reaches the bottom of that quadrant over here, so over there, as it reaches rolling down that curved path, because it's smooth, so there's no loss in energy, and that is why we have the velocity at the bottommost point from the conservation of energy, that is mgh, that is the potential energy right at the top. That will be equal to half mv squared, and both the m's get cancelled out, so you have v squared at that point to be equal to 2 times of gh. We'll keep it as such. Now the value that we can have over here is 2. We'll take the g as 10, and we'll take the height. Obviously the height is 6, so it's coming to be 120. We'll use the value as of now. We'll forget about the units. We'll be writing the units at the end. Now, so v squared is 120. Now, with the path, the horizontal path that is available, that is 10 meters distance, and there's a frictional force which will obviously cause obstruction to the motion, oppose the motion, and as a result of that, there will be deceleration or negative acceleration. So the negative acceleration that we'll be getting here is equal to the force of friction, will be equal to mass times of acceleration, which is also equal to mu times of m times of g. So equating these things, we have a, that is the negative acceleration, that will be equal to the magnitude of it will be equal to mu times of g. So that is going to be equal to 0.4 times of g, as we are taking it 10 over here. So this is 4 meters per second squared. Now from the equation of motion again, we have the 10 meters distance, the final velocity over here will be, let that be v primed. So v prime squared minus v squared, which is the initial for that motion, horizontal motion, that will be equal to 2 times of the acceleration, which is equal to negative, in this case 2as. S here is equal to 10 meters as given. So we have v primed square minus, well, v squared, as we have put it, we have kept it like that, so it is 120, and here we have minus 80. So 120 goes to the other side, so we have v prime squared to be equal to 120 goes to the other side, minus 80. So we have a v prime squared to be 40, which is the velocity over here. Now we'll keep it in that squared form as well, because we are to determine the height to which it will reach. Now, as far as the conservation of energy is concerned, it will rise to a certain height where the kinetic energy at this point will be equal to the potential energy, maximum potential energy. So as we can see, the kinetic energy over here is half m v primed square. That will be equal to m times of g times of h prime. Let's take the height over here as h primed. So m cancels out on both sides. We have v primed squared divided by g and 2 over here, that is equal to h prime, and so we have h prime to be equal to V prime square, as we know, is 40 over 2 times of g is 10. So we have the height to be equal to, well, it comes out to be 2 meters. Now, 2 meters is the vertical height that we can see over here. This is going to be 2 meters. But what about the distance that it goes along the incline? Now, because there's an angle of 30 degrees, so sine 30 is going to be equal to the the perpendicular, which is 2 meters in this case, and the distance along the incline, let that be equal to x. So you have the value of x to be equal to 2 times of 2, which is equal to 4 meters. So it will travel a distance of 4 meters along the incline. So that is how you approach these kind of problems related to conservation of energy involving friction with a bit of equation of motion. So that's it from this video. We'll be doing more of such videos. Uh, they are lined up. So stay tuned. Thank you.